Hi, this video is going to wrap up our comparison of vectors and linked lists, and we're going to get to a decision tree for how to decide between the three of them. So one last time, the goal of this little topic is to come up with a scientific approach for deciding between the sequence data structures, vector, singly linked list, and doubly linked lists, so that if you have a need to use one of these data structures, you can make a sound decision between the three. The previous videos went into the time and space trade-offs between the three of them. In this video, we're going to combine all of that information and synthesize a decision tree that can guide you through deciding between them. Let's recap that information. This is the asymptotic efficiency of the operations, in other words, the big O of them. And as you may remember, these data structures were tied with constant time for many of the operations, which is good. Constant time is the fastest efficiency class. So, that's good, but it doesn't help us make a decision. The places where there are different is that vectors cannot add or remove the front fast because of scooting elements out of the way. So the push front and pop front operations are slow linear time for the vector versus fast constant time for the two kinds of linked lists. There is a distinction on pushback that vector is constant amortized time, whereas the linked lists are constant worst case time. That's because the vector occasionally resizes itself, so that constant time is an amortized average, whereas the linked list can guarantee us it's always constant time. Okay, so that's a minor factor, but a factor to keep in mind. And then the pop back operation, removing from the back, is constant amortized time for the vector. Doubly linked list is constant worst case time, so very good for the doubly linked list. Singly linked list takes linear time to remove the back element because removing the back element requires updating the second to last node's next pointer, and you have to skip there with a loop that takes linear time. And then getting by index is where the vector shines. The vector can get index I or set index I in constant time, and the linked lists take linear time for that operation. And then we looked at the empirical constant factors. So this is if you're comparing apples to apples, two constant time operations, which one is faster? That's what constant factor means. And the science predicts that vector will be faster because it is contiguous and makes better use of CPU cache. And that is consistent with a little experiment I did where I found that the singly linked list is about 3 times slower than a vector, and a doubly linked list is about 5 times slower than a vector. So in terms of constant factors, vector seems to be the fastest. And then the other thing we looked at was space efficiency, which is how many words of memory do these data structures use to store n elements. And the vector is the most compact. It uses somewhere between 1 and 2 words per element. Singly linked list always uses 2, and doubly linked list always uses 3. So based on all that information, you notice vector was coming out pretty good most of the time there. So our recommendation, and what happens in practice most of the time, is to use a vector by default. So vector is a great general purpose sequence data structure. If you want to store a list or sequence of objects, vector is probably your go-to because the constant big O of 1 time operations have the fastest constant factors, and the vector is the most space efficient of the three. Also, vector has the feature that get index and set by index are constant time, so if you use those, then you have that available. So by default, use a vector, but then there might be a reason not to use a vector. So what would the good reasons to not use a vector be? Well, one would be if you need to add and remove both the back and also the front. The vector cannot add and remove the front efficiently. So if you need to do those things, you should look at a linked list. Another reason to not use the vector is if you just cannot tolerate the amortized performance issue. So amortized performance means that when you add the back or remove the back of a vector, usually it's fast, occasionally it's slow. There are certain applications in computing where that unpredictability is just completely unacceptable. An example of that is a real-time system like a self-driving car software or a video game where people need a response time that's very fast. Video games try to render 30 frames per second or 60 frames per second, and an occasional hiccup where things slow down unpredictably is not acceptable in those kind of settings. So if you're in that kind of situation where that amortized qualifier is completely unacceptable, then maybe don't use a vector. So let's say you've decided not to use a vector and now it's down to singly linked list or doubly linked list. How do you decide between them? Well, for similar reasons, I would say prefer singly linked list over doubly linked list because singly linked list is more space efficient and has faster constant factors. So only use doubly linked list if you really need its additional capabilities. So if you only need 3 of the 4 front back operations to be constant time, go with a singly linked list. Remember, the one outlier is pop back. So add, remove front, and add back are all constant time for singly linked list. But if you need the 4th front back operation, so you can add and remove both the front and the back, that's the situation where you should use the doubly linked list. So here it is. This decision tree summarizes all of this information. You know, there's a lot of facts and figures there, but it ended up being a relatively straightforward decision process here. First off, I would say, do you need to add to the front? If so, or if not, if you don't need to add to the front, use a vector. Do you require non-amortized performance? You know, are you in one of those real-time computing situations where occasional slowdowns are completely unacceptable? If you don't require that, then no, use a vector. So this is why vector is your default choice. You only say yes and decide between the 2 linked lists if we need the ability to add to the front or we need non-amortized efficiency. So if we're in the yes to the first decision, then the one last question is, do you also need to be able to remove from the back? And if the answer is no, we're not removing from the back, singly linked list is the one to use. But if we do need the ability to remove from the back efficiently, then that's the reason to use doubly linked list. So you can say doubly linked list here. It's a little bit of a niche thing. We don't use doubly linked list so much because you have to say yes to all of these requirements. And again, vector is your default go-to. Most of the time we can use a vector and it works very well.